To today's class, all of you. We're live here, okay? Please mute yourself. Please mute yourself. So we are there also now on the YouTube. Everything is working cool there. Okay. Okay, so we'll be starting it. Let me see how many students have joined. Cool. Let us see how many have joined. Is my voice audible? Am I audible too? Yes or no?
Yes, sir, audible.
Okay. Okay. Screen is visible to you and everything is fine. We have started the live streaming too. Fine. Please participate here. Meanwhile, you may find this video may be closed due to some technical errors. Okay. If you find this audible, voices instruct in between, so please reply soon. Don't wait. Okay. Participant is in this technical checkup. I'm audible. Yes. I'm giving you 2 minutes for this. See, it's 36, 37 seconds. I'm giving you 1 minute for this. All of you must participate. Okay. Okay, students. So JNV, all the students have participated and these also have completed. Let me end the poll now. See, how are you all? Everything is fine. See, we met Monday class was not there. There was no Monday class. So what you all did? Revise the things. What's the scenario? I mean, what you all people are doing? If I tell you, see, only 3 topics are remaining in ray optics, and then the new chapter may start. New chapter may start. Okay. So topics remaining are basically, if we see, topics which are remaining are what? Anyone? See, these are the topics. So after we have completed in your class refraction. Okay. So today we'll be seeing. Let me show you the contents. Don't worry. We'll start with the refraction through spherical surfaces, then lenses, then prism, then numericals. After that, we'll solve some numericals also. Okay. Just wait. Okay. So these are the things. See, first of all, students text me that what was the last thing which we did in your class?
ये ऑन क्यों नहीं हो रही? कल तो हुई थी ना एलईडी स्क्रीन तुम्हारी. आ जाओ.
What was the
क्या हो गया था ऐसा?
Did in the previous class? See, please mute yourself. Okay. Please, all the students, please mute yourself. In between, like the noise is coming. Okay, I'll be not wasting the time now. I'll start it. I hope on your side everything is okay. So Let us start. So in the last class we have studied refractions. Okay, refraction padha tha. We have studied what? Refraction. Today we'll start refraction through spherical lenses. Okay. After that we'll start with lenses, spherical surfaces. Sorry, refraction through spherical surfaces. We'll see this. What is this spherical surface and all these things. Then lenses. Then we'll go with the prism. Okay. Also, we'll do some numericals in between this, and then in between this. This is the complete scenario of the chapter, the remaining chapter. After prism, I'll ask from you, if you want the lecture on optical instruments, then it's fine. Otherwise, we'll skip it. Okay, I'll give you as a homework to read from the NCRT, maybe XII. And then we'll directly proceed towards the wave optics. Okay? Today's goal is what? So our today's goal is just a little bit. So always make such a goal which is achievable. So today we'll try to complete this refraction through spherical surfaces first. This is our today's goal. Let me cover, like include this in ground, like this cloud kind of thing. In animations and cartoons, we see clouds are going like this. Na? So today we have to complete this. Let us mark this as star here. This is to be completed today. Okay? Fine. Cool. You can respond in the chat box, okay, if you're comfortable here. Otherwise, okay, just see the lecture. So I'm moving towards this. So write down the notes. Refraction from a spherical surface. Write this down in your notebooks, okay? Refraction from a spherical surface. Note it down. Refraction from a spherical surface. Okay, notes must be proper. It's for you only, like, if you make the good notes, a revision is easy. See, here was the picture given. I mean, what it is trying to explain us. The picture में क्या दे रखा है? See, there is something known as refracting surface. First of all, we have seen what thing? We have seen a refracting surface like this. Suppose, sir, this is some boundary which is separating two mediums. Suppose it is separating water. This is separating water. Okay, and it is separating air above. This yellow one, let me make it with a different white color. This white boundary is separating air and water. Okay, and now suppose I will draw a normal to this. This is approximately normal. Okay, if suppose a ray is entering here like this, making an angle of incidence I, and if it's entering from this air to this water, this thing. Water is what? Denser medium, having the refractive index as 1.33. We know for water, the refractive index, say mu of water or n of water is 1.33. Glass ke liye 1.5 hota hai. For air vacuum, we take it same, it is known as 1. So when we are going from a lower refractive index to higher, it is more optically denser medium. The light ray, we know this thing clearly, that light ray is bending towards the normal R. ठीक? So this boundary is acting as a refracting surface, a planar refracting surface. Suppose if I hold this boundary from this side and this side, and I curve it like, the wrestlers, what they do, they take a bar, iron bar, and they try the big, what do we say, weightlifters and all those things. So what they do, they take the bar like this and they try to curve the bar, they try to tilt the bar, like they try to destroy it. Okay, so similarly, if I'm taking this boundary, if I'm making it curved from both of the edges, holding it and making it like this curved, okay, so you will see this kind of figure. Okay, so now we'll understand if the refraction of the ray is occurring via this planar refracting boundaries like this, so how the refraction of the rays via the objects will be occurring if the boundary is curved in this side or in that side, like bulged out in spherical mirrors we have seen, concave and convex. Got it? So this is the case here. Now suppose in front of you, this is the objective. This is what? Object. This is what? Image. Okay. So if you're keeping an object in, see, this picture, you know, it shows like we are going to derive something, but I am not going to derive here some anything. Okay. We need just applicative formula. Application के लिए formula चाहिए बस. We not only this thing. We want only this thing. ठीक है? Clear? Okay. So see, if the object is here, ray is coming like this, it will deviate upwards. Let me draw it in the proper figure here. Okay. So see, object का distance यहाँ से I'm taking it as u. Okay. This is what? Object distance. This is object distance. And distance of the image, if I see image distance का what the distance of the image formed for finding the image distance if the object distance is given. देखो, one thing is common. One thing is common. Understand like this. Let me show you on the flow chart there. Yes. So I am drawing a flow chart here. It will give you, you know, a good understanding of how we started. So when we, when we have started this topic, that is plane mirror, we have seen this thing that if we are having a plane mirror, if an object is present like this in front of the plane mirror at a distance d, we know this thing, image will be forming d distance virtually inside. This was the law, no? And how was the formula? Formula was like this: distance of the object, from the mirror perpendicularly is equals to distance of image from the mirror perpendicularly. Okay, this was the first thing. That what we did. After this, we proceeded towards the next thing, that is image formation due to spherical mirrors, not surfaces. Surfaces is just now recently where I've changed the slide. Spherical surfaces, sorry, mirrors. Spherical mirrors. So we are having mirrors there, okay? And we have seen in case of spherical mirrors or like this, image and object distance. If you see the formula, what was the formula? 1 by v plus 1 by u equals to 1 by f. This is the mirror formula where f equals to r by 2. This we have seen. Then we proceeded towards what? Then we proceeded towards this, which is now we are going to do. That is via spherical surface refraction. Image formation, when the object rays get refracted, these above 2 points are what? Above 2 diagrams are for what? Reflection. But now image is formed not due to reflection, but due to refraction. Okay. So spherical surfaces jab aate hain, how the image is formed. Suppose the surface is like this. It will be not polished. Polished is shown by these kind of sticks. It's not polished. So the formula will be what? Formula will be this now. Suppose if there is a surface, refracting like this, which is separating two mediums, say medium which is having refractive index n1 and medium having refractive index n2. Okay. And the object is present in front like this. And the image is formed here somewhere. Suppose like this, if the conditions are this. Object distance is u, image distance is v. So you'll use this formula, and radius of curvature of this is given as r. Okay, so you will use this formula if the u is given, everything is given, and they're asking you to find v, that is object distance. I'm highlighting this. Please note it down in your notebooks. This is important formula. Based on this formula only, we are going to solve the questions. Based on this formula only, we are going to solve the questions. Okay, Chandigarh region में complete नहीं हुआ था ना? These things haven't completed. Am I right? That's why only I'm solving it now, you know. So please note it down. If you have noted down, please text here in the chat box. Okay, Jyoti have also joined and many other students have joined. That's good. So if you have noted down, please text in the chat box so we can move for this the next slide. Okay. See students, if you see the formula here. Okay, JNV Shimla students have joined. Very good, excellent. So you're responding. It shows that you are you're concerned about your studies. Like you focus here. See, important points for above formula, where this formula is valid, what's the validity? You know, everything is having the validity. Biscuits, anything, you know, everything, anything. Whatever if the food you take outside, it's having validity, you know, otherwise if you take after that, it's not good. So what I mean, here, what are the valid points? This is the pass, you know, entry pass for validity of this formula. Otherwise, if these points are not satisfied properly, you'll get wrong answer either this formula is not valid for you. So the first is this paraxil. Paraxil matlab what? Break the words. Para, parallel. Something which is parallel. Axil matlab what? Near to axis, making very small angles. Axis ke near. So rays must be like this. This we have seen in mirror case also, that is concave or convex. U, which is the object distance, V, which is the image distance, R, which is the radius of curvature. All these things should be put along with the sign. All these things you should put along with the sign. Mu2 is the medium in which the ray is going. Okay. Matlab, see, as remember, don't get confused. Students don't get confused. ये N2 mu2 सब एक ही है. Everything is same here. You like, you know, sorry, you have put here N2. What is this? Initially you have put mu2. Mu2 matlab refractive index. N2 matlab refractive index. Both of the second medium. Okay. So in front of you here, mu2 is for this medium, N2 and mu2 are replaceable things. Mu1 is where the medium where the rays are coming from, which from which the rays is coming. It means the object is placed here. Object is placed. Okay? Formula लिख लिया? If लिख लिया, then solve this question now. This is a class illustration. It's a class illustration. See, इसमें you need not have to check even what's the sign in conventions of the value you are going to put in the formula, because already if you see students with your eyes, if you see this thing, already here the sign in conventions are already given. See this, so it's a help for you. Next question it will not be provided. You can see here carefully the sign in conventions are already given. Okay, apply the formula. Formula क्या था? It was like this: n2 minus n1 with proper sign and convention are n2 upon object not image distance minus n1 upon object distance. Apply this formula and get your answer. Be happy. Okay. So I'm giving you 1 minute for this. Apply this. See, everything is given in front of you. Object distance 30 centimeters, but that's its magnitude. You have to see what is the sign and convention. It's given minus 30. Help. Radius of curvature is positive. Of course, you can see it. It's in the positive direction as per the object rays in that same direction. N2 is 1.5, N1 is 1. It's in the air. If nothing is given, take the vacuum. If nothing is given, take the vacuum. N1 is 1. Apply the formula. Where you will find the image distance magnitude. V will be how much? I solved actually by giving all these things. We have solved the question more than 75%. Text your answers in the chat box. We are waiting. Try to solve this. What do you think? What do you answer? Please text your answer in the chat box. I'm waiting for your solutions. I mean, not solutions, not just answers. V kitna aega? What is the image distance? I don't want to tell like in nature kaisa hoga. I don't want from you people to appropriate ray diagrams. I just want V. You can delete this part of the question. This part is deleted. Okay. Anoop have given the answer. Anoop have given the right answer. I think 90 centimeter is the answer. Very good, Anoop. What about other students? What the other students are doing? Okay, Rachna, like you also have given the answer excellent. Okay, very good. What about other students? What you are doing? Okay, I'm solving. Time is up. Time is up. ऐसे थोड़ी है like I'll not be giving you many minutes, है ना? You know this thing. This is a rule. Jyoti have given 90 centimeters. Everyone is giving 90, 90, 90. Let us see, is it right or wrong? Maybe minus. See, just apply the formula here. It's n2 minus n1 upon r, n2 by v minus n1 upon u. You know, convention ke saath u is already given here minus 30 plus 10. It's minus 30. R is already given with sign convention. So it was just, you know, pick it, put it there. Pick it and like fit it there. Okay, you'll get the answers. N2 kitna hai? Glass. It's like, no, it's water. No, it's glass. Yes, glass is having refractive index 1.5. N1 is air. 1.5 air. ये solve नहीं होता क्या? It's very easy, no? 1.5 minus 1, 0.5. मतलब half. This is 3.3 by 2 V minus 1 by minus 30. Minus minus plus. Okay, one student have texted me. Okay, JNV Chandigarh students. Cool. Okay, so you are from Chandigarh. Okay, that's fine. Okay, no issues. So you must at least you must understand this thing. Like, you know, you have been notified. Okay, cool. Very good. So we'll write here 120. Thanks for notifying me this thing. Okay, you're from JNV Chandigarh. Okay. So all the students may be from whatever, whichever JNV. Okay. If you're understanding, that's fine. You can text your doubts here also. Okay. 120 minus 1 by 30. And this is what? 3 by 2V. This is what? 20 by 30. And what will be the solution? Simple. It's 60. 3 minus 2. 3 by 2V. This is 30. This is 1. Sure, the answer is 90 centimeter. Brilliant students. Very good. All the students from like JNV, Chandigarh, and all of the students. Yeah. So all of your answers are right. Okay. V equals to 90 centimeter. All the students who got this answer, it's right. Very good. So we'll, if I show you the ray diagram, you know, a simple little bit, you know, overview. So I'll say like this, that I is positive. Positive matlab if I am or you are standing here. Okay. So negative direction will take this, positive you will take this. If you take this as origin also, let us go mathematical. Cartesian coordinates. That also will work here. Okay. Sync, the things must sync. Okay. Sync matlab synchronization will be there. If you're going in the object rays, it's positive. If you're going opposite to the object rays, it is negative. यहाँ पे positive is this direction. 90 positive. मतलब यहाँ से 90 positive जाना है. So you are 90 centimeter right. This is the image. This is the image. ठीक है? Fine. Answer आ गया? Okay, so इसमें we'll consider I'll write here n2 minus n1 upon r. So this completes our flow chart up to these three cases. Okay? Now solve this question. This is a question for you now. Solve this question. This is also surface, but the challenge for you people is this now. You have to put the radius of curvature value with sign and convention yourself. You have to check whether it is plus, minus, minus, plus. I mean, whatever. Okay. Plus, you have to see whether u value is plus or minus. Okay. Put the sign and conventions, put these values with the sign and conventions and find out the answer. Formula pata nahi kaun sa apply karna hai? Same. N2 minus N1 upon you know the reason? It's refracting surface. Mirror nahi hai. It's refracting surface. Question is again same. You can delete the next of the part. Next part is this appropriate ray diagram, not required for you, because how you'll show me? No need to share the screen. Just put the answer in the chat box. So find the image. मतलब image का distance कितना है? I'm asking from you people this. Find the V position of the image. मतलब victory V. Find this. What is V? Image distance. Image का distance कितना है? I want the answer. I'm giving you a few minutes. मतलब यहाँ से यहाँ है, or the image is on that side only. You have to find this V value with the sign, proper sign and conventions. This is a challenge for you. Initially, they have already given you the sign and conventions, but here that's not the case. That is not the case here. Okay? Okay. Answer here. You can answer now. I'm giving you a few minutes. Say 1 or 2 minutes, okay? Okay, JNV Chandigarh students have given the answer excellent. It's minus 30 by 7, they say. Okay, we'll check it out, okay? Have patience. I think that you must cross-check it. Is it right? Minus 30 by 7. I'll check it. It's excellent, you have texted, but we'll cross-check with the solution, okay? Just have patience. Let us wait. Okay, so all of you have texted. Okay. Yeah, JNV Shimla students are saying minus 6 centimeters. Maybe the answer is right. Maybe. Okay, I'm solving. Please be focused here on the slides so you can check how you approached. Simple question. Very simple question. Refracting surface is like this. Okay. Object is placed here at 5 centimeters from this center, looking like point. Center, like it's look like center point. And here refracting index is 1.5 for this, and here it is 1. Okay. The radius of curvature here is given as 10 centimeter. Okay, radius of curvature 10 centimeter. But if you focus here, this curved surface is center is curved surface ka center. If you want to check the center of this curved surface, of course it will be in this direction, maybe somewhere here, C, center of this curved surface. It will complete a spherical kind of thing. So it will be center. Suppose this is somewhat near, not there. Okay. You can consider like this, no? Let me make a proper diagram. Just hold on. Read this part. Yes. So I will say here, object may be located here. Center, if I complete it, I can call center will be somewhat here, C. Okay. And this is the axis. So this is what? Center of curvature, by the way. Center of curvature, COC, center of curvature. Okay? Curvature. And curvature is what? This. Take. So now they're asking from us to find the V. Simple. If the center of curvature is located at this side, radius of curvature, of course, will be located at this side only. Hai? So we can see from here that radius of curvature comes out to be against the object rays, it is negative. Or you can take origin here conventions. Some people like to do this, but you also have to check the object. It's the best thing to also check the object and put the values. Always you will get the right answer. Okay. Now simple, apply the formula and the answer is in front of you. N2, refractive index of second medium, first medium R, second medium V, minus aega, never forget, it's always minus. First medium U. Again, you'll get 1 by 2. I'm solving fast. R is what? R value kitna de rakha hai? It's 10 centimeter given. It is negative, minus 10. N2 is 1.5, 3 by 2. Because 1.5 is what? 15 by 10. 3 is 15, 2 is 10. N1 is 1. U is what? It's against the object. It's negative direction. Minus 5. Minus 1 by 20. Minus, 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 plus. Again, left hand side, minus. 3 by 2V. Okay? If you will solve this thing, क्या मिलेगा आपको? Minus 1 by 20 minus 1 by 5. This will give you answer as minus 5 by 20, which is equals to minus 1 by 4. ठीक है? If it is minus 1 by 4, this is equals to 3 by 2V. This is twice. I think JNV Shimla answer. Very good. Clap. So over that, like JNV Shimla, yeah. So your answer is right. JNV Shimla students minus 6. Maybe, like other students have done some mistake who got some other answer. Okay. Check your method. I think you applied the same concept, but you have done some mathematical, mistake there. By mistake, you have done some mathematical kind of error there. Okay. No issues. That is right. Understood this? Yes or no? Students, yes or no? You got this point? If yes, we can proceed towards the next lenses. Okay, we can proceed towards the lenses then. Cool, very good, very good. Take, okay, complete. So one thing you understood from this. किसी -6 का मतलब क्या हुआ? -6 का मतलब है that the image formed will be not in this direction now. It will be in this direction. So it will be 6 centimeters from this point, red point. Image will be here. And the ray diagrams, somewhat I will give you overview. Ray diagrams will be like this. If this is the normal, it will be diverging like, it's diverging like this rays, and it will give you image like this. Okay, backside when extended. A rough diagram. Okay, although it's not required for you to draw. Now let us proceed towards the lenses. Okay. Some points are there on the PDF. Okay, I'll annotate them and you have to read them. But now we have to complete the syllabus fast. So I'm proceeding towards the lenses now. Okay. Combinations we'll see after. I'll give you the PDF. Try the PDF, and the next Monday come. I'll ask from you. Okay. I mean, if you are comfortable with the understanding of the annotations or not. Write this heading lenses now. Refraction through mirrors. We have seen plane mirrors, spherical mirrors, concave and convex. We have seen refraction through spherical surfaces, big formula. Now we'll see the formula for refraction through lenses. Lenses means lenses, you have seen in the geometry box, your geometry box. Earlier time we were having geometry box for, maybe 9th, 10th classes, big boxes. In that many material was there, protector, degree, D, compass. And what was the thing? Lens also used to come, a small plastic case can that covered lens, circular curve. So what we used to do, we go outside to play and we, dry leaf, we see the dry leaf. And when we put that lens in front of the sunlight and behind this, like below that, we put the paper or a dry leaf. If you keep it just for a few seconds or somewhere like the lens is powerful, less than seconds or like for a minute, the smoke starts from the leaf or the paper there, or it may catch fire. It happens, no? So that is all the power of lens, power of the lens. You know what it does? All the rays of the sun, which are, bikri means what? All the rays of the sun, which are like, here and there. Okay. I mean, they're not properly concentrated at a point. So rays which are randomly distributed, of sun rays which are randomly distributed here and there. Rays are what? These are energies. These occupy in them what? Like, packets of energy. Okay. So when the rays are here and there, they are like randomly distributed. So lens does what? Lens, all the rays which are like falling on the lens at all the points, circular, like, area, it concentrates all the rays on the other side of that surface at a particular point. So when you're concentrating all the rays like this and making them molded, at like a single ray, so that is having more energy. Okay, that's why more heat is produced at a single point, and you are able to destroy that wood. I mean, you're able to create the smoke, generate a smoke from that. So that is due to lens. It's a practical application we have seen when we were, lower classes. Okay. So for now, I hope you have written this heading. Please write the definition of the lens. A lens is a transparent medium bounded by two refracting surfaces, such that at least one of them is reflecting surface is curved. Okay. So it's like this, students. If you take two refracting surfaces, we have now only seen. If we combine them, we'll get different combination of lenses. This is like a plane refracting surface. This is like bulged in concave. This is like a convex. This is like concave. So you can see it's convex bulged out. It's also convex bulged out. So it's convexo lens or biconvex. This is also bulged out. This is also bulged out. But why it's written equi? Because here the radius of curvature of both the bulged out surfaces were not same. Here it is same. That's why it's equal. Take out the word break the word equiconvex. Here the surface is planar. We have seen the plane reflecting surfaces also. Here it is bulged in. So plane convex. Hold on, it's convex. Yes, it's convex. It gets bulged out, not in. Plano concave. Yeah, it's bulged out. If you see from that surface, okay, it's bulged out. If you see here, it's bulged out. Here, if I come, it's bulged out or bulged in. Anyone? It's bulged out. We'll call it convex. It's bulged in, concave. So concave or convex. Biconcave. Concave and concave. Equiconcave because both are having the same radius of curvature. Planar, concave. Convexo, concave. ठीक है? Remember, convex or concave होता क्या है? See, concave is bulged in. Now this is concave. Remember, if some mistakes you are finding here, you can just change it. It's not a big deal. Okay. Convex is what? Convex is bulged out like this. See, it's how, from which side you are looking. It also depends. If you're standing here, I'll call this as concave. And this is convex. If I'm standing on the same side, this will be convex for me. Okay. If you're standing on the other side, same can be behaving like concave or convex. So if we copy the surfaces and combine them, different surfaces, we'll get a quantity we'll get a thing which is known as lens. And these are different combination of sets of, different sets of lenses. You can select anyone, whichever you want. We go in the shop and we want to show me this kind of lens. So these are the lenses here. Got it? Right, note it down in your notebook fast. Note it down in your notebooks. I'm giving you the time. Okay, one more student have joined. That's good, but no issues. You can start from the lenses only. Note it down. After this, I'm moving towards the next slide now. Okay. I'm moving on the next slide. Fine. Yeah, write this principal axis. What is this principal axis now? So if you're taking, suppose, see, if I'm having the different center of curvatures, sure, I'll be having different radius of curvatures, which are linked with this center of curvatures. So this gives me a lens, which is biconvex lens. Okay. And if I see this, this is again R1, R2, but this is biconcave lens. Bi matlab different. Bye. Not that bye, it's different. Okay, don't take that. So we say the line joining the center of curvature of two bounding surfaces is called principal axis. Okay, two bounding surfaces matlab देखो ये अगर C2 है, C2 will be of this, इसका center, इसका radius of curvature R2. C1 will be of इसका center, इसका radius of curvature R1. C1 will be इसका center, इसका radius of curvature R1. C2 will be इसका center, इसका radius of curvature R2. Simple. I repeat it again. You want me to highlight this? Line joining the center of curvature of the two bounding surfaces is called principal axis. ठीक है? Simple. Note it down. Okay, have you noted it down? Okay, let us move toward the next. So students, in the series, in the flow chart of our formula of the images formed by different things, if I show you the flow chart again, see, this was our flow chart. We reached where? Okay, let us come back to the flow chart. This is our flow chart we have generated, we have made now. Take out the print of this. Okay, not required, just see the PDF whenever you want. See, we started from this. We started from this plane mirror. ठीक? After this, we went to the spherical mirror. So in these two processes, if you focus, image is formed due to reflection. In these two, image is formed due to reflection. Okay? And in this, image is formed due to refraction. And if we see the formulas are changing very rapidly in shapes and also in conceptual wise, understanding wise. Mathematics is also now, level is increasing with the formula. From here to here, if I jump, this is the formula. From here to here, I jump, this is the formula. So in this series of image formation by different mirrors and surfaces, now we'll add one more. That is image formation. Image formation due to lenses. Okay, so I'm taking a very simple, say, biconvex lens, not having the same radius of curvatures. If you take this lens, it's like a leaf. See, this is the optical center of this lens. ये क्या है? Optical center. Suppose students, what to do? Suppose I'm placing an object here. If I place an object here, okay, image will be formed here. This is what converging lens. Okay. So students, now if we focus here, what's the formula? Formula is this. If the object distance is u, v is the image distance. Okay. So it's very much similar to the formula of the mirror. In that mirror, spherical, I mean concave and convex mirror, due to reflection, the formula was, 1 by v plus 1 by u equals to 1 by f. Here the formula is very much simple, but only one thing will change. That is 1 by v minus sign will come, u equals to 1 by f. This is one thing which is changing in this formula. As per, like, if we look at, this is only the change. But if we go inside, these things are same. This is the image distance you have to put with the sign and conventions. Hold on, maybe you're finding some noise. See, this thing is same. That is image. This is image. This you have to put with the sign and conventions. Sign and conventions. This thing is also same. That is object distance This also you have to put with the sign and convention. This thing is changed. This is focus. Mirror में कितना था? Mirror में we have seen the flow chart. If you see the flow chart, mirror में it's very simple. Radius of curvature का half. इसमें this is not a thing. This is not the same. Okay, now it is changed. It's very big now. Okay, so the focus here is defined as, तो कैसे define करते हैं? We define here the focus like this. If you are given a lens, and if refractive index of the material of the lens, suppose this is a किसी glass का lens हो सकता है ना, lens can be of the glass. So if refractive index of is given as mu, suppose कुछ भी है, water का lens है, jelly का lens है, किसी का भी lens है, suppose some crystal का lens है, ruby diamond, किसी का भी lens है, okay. So suppose this is what surface, this is also mu is some jewels kind of lens है, you know, whatever. And the object is present in front, image is formed here, and object distance is u. This is something, the center of the lens is named as optical center. We'll measure all the distances from this optical center with proper sign and conventions, plus minus minus plus, as we did in the spherical mirrors, concave or convex, starting from the center point, that is apex point था ना वो, pole or apex. इसमें suppose image is formed here, you will understand this is a converging lens. Converging मतलब सारी rays को पकड़ के focus करके एक intensity में increase कर देना, ठीक है? So after this, if you apply here the formula, what kind of formula you can apply? कैसे? What the formula which we are going to apply here? If we see the focus, see focus will be this 1 by f. Formula is changed now. I'll write like this: mu L upon mu S minus 1 upon R1 minus 1 upon R2. What are these R1 and R2? या R1 R2 क्या है? What are these? See, अगर इस surface को देखोगे तो इसका तो ये क्या है? See, जैसे if you're going from the object side, this is the first surface, second refracting surface. So radius of curvature for this is defined as R1. Radius of curvature for this is defined as R2. So now you have to be very much focused for the sign and conventions. ठीक है? So put the formula here. Okay, let me take the different good colors. These are goody colors. Okay. So I'm marking this in the cloud again. So this is a focus defined. And now you will put this focus here. So you'll get a very big, you know, jumbo combo formula. This is a very big formula. So what is it? Mu L upon mu S minus 1. It's very big, very big, very big, very big, R2. Okay. Let us cover this in indigo color. Indigo. So I have covered this in cloudy thing here. You can see. This is a formula. So see, flow chart, you know how it works. This is a good no. So starting with play mirror, very short formula. See the formula, kaisa hai? Chota sa. Let me highlight with laser pointer. So this is the distance of the object. Mirror formula you can see. Okay? This is when image is formed due to refraction by a single surface is curved this side or this side. Then we have seen this thing. This is image formed due to what? Lenses. Okay, and you can see the formula, how it's changed as compared to mirror formula. If you see its big version, complete version, it's like this. Okay, 1 by V minus 1 by U, mu L, mu S minus 1 upon R1 minus 1 upon R2. Okay, 1 by V minus 1 by U equals to 1 by F. Finish. Okay, now let us move towards the next. So this was all about the lenses. Now we'll solve one question. Okay, not this. Rest of the things will be given to you on the PDF. Okay, solve this question. Yeah, this is the last question of today's class. After that, in the next class, we'll start directly with some of the recall questions from refraction via surfaces, spherical surfaces, and lenses. Then after this, we'll see prism. Prism ke baad, we'll end the class. I'll ask from you, do you want optical instruments lecture also? It will be just 20 minutes. Or you want wave optics? Okay? So focus here. This is the question. Calculate the focal length of biconvex lens in air if the radius of its surfaces are 60 centimeter and 15 centimeters. Okay, try to solve it. It's a class illustration for you. This is the class illustration for you. Try to solve this thing. Okay. Class illustration. I'm giving you the formula here. Biconvex lens is like this. This is biconvex lens. Okay. Surfaces are given 60 centimeter and 15 centimeter. 60 centimeter किसके लिए? इसके लिए 60 centimeter. This is the radius curvature of the first reflecting surface connected together with this R2. That is 15 centimeter. Refractive index of the lens is 1.5. ठीक है? Formula apply करो. 1 by V minus 1 by U equals to 1 by F. 1 by F is mu L upon mu S minus 1. 1 upon R1 minus 1 upon R2. Apply and find the answer. Okay, time is less. I'm giving you this as a homework. Hint I have given in front of you. Okay? Got it? We are having the less time, no? Time nahi hai itna. Time is up, okay? Because it's like 5 p.m. You know? Cool. Did you understood this? All the students, JNB, Chandigarh students and Shimla students and all this, है Okay, fine. From some other JNB maybe. Praveen and all. Okay. So now I'm ending it. Okay. This will be given as a notation on a PDF to you. Fine. Complete. I'll give a book. I'll give like a file. I'll also give you some books here. Okay. I mean, maybe in that drive I'll upload there. Okay, you can check it out. But till morning. Like today, I'll try to give this thing like annotation. Okay. Annotation will be provided. No issue. Extra things tomorrow. If you want today, you can take. Okay. Emergency if you. So this, I'm ending it. Thank you for your attendance. Very good. You all are coming regularly. Okay. So I'm, starting the poll here. Please participate. I've launched the poll. You can participate in the poll or you can leave them. Fine. Okay. Okay. Bye-bye all the YouTube students. I'm stopping this live stream. Time is up. Bye-bye. Study well. Take care. You can solve Harish Chandra Verma, SCV, Concept of Physics, Part 1. At the end of the chapters of the Part 1 of 11th class Wali, if you solve that, you will find the ray optics and wave optics there. Ray optics ki theory is fine there. Optical instruments so good written there, I mean, it's like more than enough. And then you can solve the numericals also. Okay?